This is a video from section 12.3 based off the lecture notes. Recall, if theta is the angle between vectors A and B, then the dot product of A and B is equal to the magnitude of A times the magnitude of B times cosine of theta. And remember that theta is an angle between 0 and pi. We have a note. 1. Two vectors A and B are orthogonal, or you can say perpendicular, if the dot product of A and B is 0. Let's see why that's true. So if A dot B is equal to 0, then the magnitude of A times the magnitude of B times cosine of theta is equal to 0. But we're talking about non-zero vectors, which means the magnitude of A and the magnitude of B cannot be 0. And so what that says is that the cosine of theta is equal to 0, and the way that can happen is if theta is equal to pi over 2. And so the angle between the vectors A and B is pi over 2. So it will look something like this. So when you have two perpendicular vectors, you know that the dot product of A and B must be 0. And if the dot product of A and B is 0, then you know that the vectors are perpendicular. So it works both ways. And then on number 2, two vectors A and B are parallel, which means one vector is a scalar multiple of the other vector if theta equals 0 or theta equals pi. Now, let's take a look at an example. It says, find the angle between the vectors. And then we have A is the vector 1, negative 3, and B is the vector negative 3, 4. Now, the magnitude of A is equal to the square root of 1 squared plus negative 3 squared, like so. And that's the square root of 10. The magnitude of B is the square root of negative 3 squared plus 4 squared, which is equal to 5. So if I take the dot product of A and B, so we'll figure out what that is here. This is 1 times negative 3 plus negative 3 times 4, which is equal to negative 15. Now, negative 15 is equal to 5 times the square root of 10, so the magnitude of A times the magnitude of B, doesn't matter the order, times cosine of the angle between the vectors. So cosine of theta, if I divide both sides by 5 square root of 10, I get negative 3 over the square root of 10. Okay, and so theta is the inverse cosine of 3 over the square root of 10. And I'll leave it to you guys to get an approximation in degree. This book says to get an approximation in degrees, but I will leave that to you guys to figure out. So this is, by the way, the exact value. Example 2. I left a little room there. If A is equal to the vector negative 1, 3, 4, and B is the vector 5, 2, 1, we want to find the angle between the vectors. Okay, so the magnitude of A is the square root of negative 1 squared plus 3 squared plus 4 squared. So I'm just trying to do the hard work here. And so that's the square root of 26. The magnitude of B is the square root of 5 squared plus 2 squared plus 1 squared. And that's the square root of 25 plus 4 is 29. 29 plus 1 is 30. So we get a 30 there. And then A dot B is equal to negative 1 times 5 plus 3 times 2 plus 4 times 1. And so if I simplify that, negative 5 plus 6 is 1. 1 plus 4 is 5. And so we're going to go this way. So I'm going to take 5, the dot product of A and B. That's the square root of 30 times the square root of 26 times cosine of theta. I do expect you to be able to simplify that somewhat, okay? So I'm going to come up here. Remember that square root of 30 is the square root of 2 times 15, right? And the square root of 26 is equal to the square root of 2 times 13, right? So let's write that a little neater. So if I take the square root of 30 times the square root of 26, I know that 2 times 2 is 4. Square root of 4 is 2. So I'm going to pull out a 2. And I'm going to multiply that by the square root of 15 times 13. So if we figure out what that is, 15 times 13 is 195. So we get 2 times the square root of 195. And I cannot go further than that, right? And so if I come up here, we get cosine of theta is 5 over 2 times the square root of 195. And so theta is the inverse cosine of 5 divided by 2 square root of 195. And again, I will leave it for you all to put that in your calculator to get a degree measure. And that's example 2. Now the directions say to determine whether the given vectors are orthogonal, which just basically means perpendicular, parallel, or neither. And so what I like to do is I like to check for orthogonal. That's always a good one to check for first. And if orthogonal doesn't work, then I go for parallel. And then, of course, if parallel doesn't work, then it's neither. So if I take A dot B, well, this is 9 times negative 2. So I'm going to multiply the first components. And then I'm going to multiply the second components and then add the results. So 9 times negative 2 is negative 18. Negative 18 plus 18 is equal to 0. And since I got 0, what that tells me is that A and B are orthogonal. And I'm done. That's how you do example 1. Let's take a look at example 2. Suppose I had the following. Suppose A equals the vector negative 8, 12, 4. And suppose B is the vector 6, negative 9, negative 3. And so, just like in the last one, I'm going to look at A dot B. Well, that's negative 18 times 6 plus 12 times negative 9 plus 4 times negative 3. So it doesn't look like it's going to be 0. And so this is negative 108 minus 108 minus 12. So that looks like it's negative 228, which is not 0. And so I can tell you that vectors A and B are not orthogonal. Now, from here, we need to check parallel. So I'm going to look at the magnitude of A. Now, A is negative 18, 12, 4. And B is 6, negative 9, negative 3. So I'm going to get the square root of negative 18 to the second plus 12 to the second plus 4 to the second. Now, 12 to the second is 144. So I'm going to put 144 there. Plus 4 squared is 16, okay? And then if I take 18 and multiply it by 18, I get 324. And so if I take 324 plus 144 plus 16, I get the square root of 484. And the square root of 484 is 22, it turns out. And then I'm going to take a look at the magnitude of B. Well, the magnitude of B is the square root of, now, B is 6, negative 9, negative 3. So I'm going to get 6 squared plus negative 9 squared plus negative 3 squared, right? And so this is the square root of 36 plus 81 plus 9. And what that tells me is the magnitude of B is, that looks like the square root of 126. And if we simplify that a little more, this is equal to 3 times the square root of 14. So just to let you know, this is a process, okay? So from here, remember that A dot B is negative 228. The magnitude of A is 22. The magnitude of B is 3 square root of 14. And so negative 228 is 66 times the square root of 14 times cosine of theta. And certainly, theta does not equal 0 or theta does not equal pi. And so therefore, vectors A and B are not parallel. So the answer is neither. Then let's do one more on this one. What if I give you something like this? Suppose A, we'll call this example 3. suppose A is the vector 9, -6, 3, and B is the vector -6, 4, -2. So I have an example where the vectors are orthogonal. I have the answer a pair of vectors where the vectors are neither. Now, let's take a look at this one. Now, A dot B is equal to 9 times -6 plus -6 times 4 plus 3 times -2, right? So we get -54 minus 24 minus 6. That looks like -84. If I take the magnitude of A, I get the square root of 81 plus 36 plus 9. And so if I add those up, I get the square root of 126. And if you guys remember, that tells me this is 3 times the square root of 14. If I take the magnitude of B, you get the square root of 36 plus 16 plus 4, which is the square root of 56, which is 2 times the square root of 14. So this is a good question, because check this out. We get -84 is equal to 3 square root of 14 times 2 square root of 14 times cosine of theta. So -84, remember that square root of 14 times square root of 14 is 14. 14 times 3 times 2 ends up being 84. So this is 84 cosine theta. Okay? So cosine of theta is -1, and that tells me theta is pi. And so once theta is pi, that tells me A and B are parallel. Now, if we go back to this example, so just kind of a quick comment. If you look at the ratio of the first components, you get -3/2. If you look at the ratio of the second component, and of course reduce it, right? You get -3/2. And if you look at the ratio of the third component and reduce it, you get -3/2. And so it does turn out that A is a scalar multiple of B, but sometimes that's not always going to be obvious. And therefore, this method can be helpful in determining whether or not two vectors are parallel, because sometimes it's difficult to find that scalar. And that'll conclude this video for section 12.3. And this is, again, based off the lecture notes, and this will be part 2. Okay, thank you.